Alright, in this video I'm just going to be walking through my work for the study guide, so you can check yours. So we have triangle similarity unit. The first question says the angles of a triangle have the ratio of 8 to 3 to 4. Find the measure of the smallest angle. So I know that the measures of the angles in a triangle should add up to 180. So 8 times as big as the number, so 8x plus 3x plus 4x equals 180. I'm going to combine my like terms. So I get 15x equals 180. Divide by 15, so x equals 12. Okay, and then it says find the measure of the smallest angle. So the smallest is the 3. So 3 times 12 should be 36 degrees. All right, so the next one is, it says the sides of the triangle have a ratio of 9 to 12 to 5. If the perimeter of the triangle is 130 meters, find the lengths of each side. So let's go ahead and set up an equation. 9x plus 12x plus 5x equals 130. Combine my like terms. 9 plus 12 plus 5 is 26. X equals 130. Divide by 26, so x should be 5. Plugging that in for each, so 9 times 5, 12 times 5, and 5 times 5. So we should get 45 meters. 12 times 5 is 60, so 60 meters and 25 meters. I could double check by adding these up, and they should add up to 130. Next one says two complementary. So complementary means they add up to 90 degrees. I have the ratio of 10 to 8. Find the measure of the angles. So 10x plus 8x equals 90. So 18x equals 90. Divide by 18. X equals 5. Find the measure of the angles. So 10 times 5 is 50 degrees. 8 times 5 is 40 degrees. And the next one, an isosceles triangle has the ratio of base to vertex angle of 4 to 7. So if I have an isosceles triangle, do my best here. Okay, so these two sides are the same, which means these base angles here should be congruent. So if it's base to the vertex, that means the 4x is these bases, and the 7x is up here. Find the measure of all angles and classify by angles. So 4 plus 4 is 8. X plus 7x equals 180. So 15x equals 180. So x equals 12. Plug that in. So the 7x side, 7 times 12 is 84 degrees. And then the 4x side, 4 times 12 is 48. And then we have another 48 degree angle. So we can classify this as acute. None of these are over 90. Number 5, find the scale factor of A to B. So A to B, I will pick the bigger of the two numbers, 36, over the bigger of the two numbers over here, 20. I can reduce these by dividing by 4. So 36 divided by 4 is 9. 20 divided by 4 is 5. So the ratio is 9 to 5. I can write it like that, or I can write 9 to 5, or 9 to 5. Either way, A to B. Order does matter. Next one, find the scale factor of b to a. So I'll go ahead and pick the shortest side here, 9, over the shortest side over here. And notice it looks like it's been turned. So the shortest side is actually the 12 here. So be careful as you're going through these. All right, so 9 over 12, if I divide both of those by 3, we get 3 over 4. That is our scale factor. 7. Given that these two triangles are similar, find JK. So I'm going to need to set up a proportion here. I'll put my left triangle on the tops, so 25, 4x minus 23. Okay, so KL, 25, trying to figure out what goes underneath it. KL, first two letters, corresponds with VW. VW is 20, so 20 goes under here. 2x plus 2 goes under here. Didn't leave you a ton of room, sorry about that. Let's cross multiply. 25 times 2 is 50x plus 50 equals 20 times 4 should be 80. And then 20 times negative 23 should be negative 460. Combine like terms, so subtract the x's, so I should get 30x. And the 50 plus 460 should be 510. So x should be 17. I was asked to find JK, so J to K is here. So 4 times 17 minus 23. So JK, 4 times 17 is 68 minus 23 is 45. Number 8, given that these two triangles are similar, find MS. So let's go ahead and set up our first proportion here. Let's do the triangle on the left first. So 28 on the top of this one, 3x minus 1 on the top of this one. The other triangle, so 28 is ML. So ML corresponds with RL. RL, so 24 will go under here, and x plus 7 here. Cross multiply. So 28 times x is 28x. 28 times 7 is 196. On the other side, 24 times 3x is 72x. And 24 times negative 1 is negative 24. Let's combine our like terms. So subtract 28x and I get 44x. 196 plus 24 should be 220. Divided by 44, so x should be 5. Now I was asked to find MS, so maybe I'll grab a highlighter for you. MS is this entire thing here. So I know that's 28. This part would be 5 plus 7, which is 12. So 28 plus 12 is 40, so MS equals 40. Number 9. Given that these two triangles are similar, find KL. So let's set up a proportion. Alright, so 10 over something, and then equals x plus 11. 10 is ED. ED corresponds with JK, first two letters. So JK, 25 will go under here, 6x plus 3 here. Cross multiplying, 25 times x is 25x, plus 25 times 11 is 275. 10 times 6x is 60x. 10 times 3 is 30. Combine like terms. 60 minus 25 will be 35x. 275 minus 30 should be 245. Divide by 35, so x equals 7. And I asked you to find KL. So KL is here. So we'll do 6 times 7 plus 3. 6 times 7 is 42, plus 3 more is 45. So KL equals 45. Okay, last one on this page. We want to do same thing, find PT. So let's set up our proportion. I'll do my triangle, this triangle first. So 2x minus 1 will go on the top. 4x minus 26 will go on the top over here. So SR, second last two letters corresponds with QR. So Q to R. So 38 will go underneath that one. And then 60 underneath here. Got some larger numbers. So 38 times 4x is 152x. 38 times negative 26 is negative 988 equals 60 times 2x is 120x, and then 60 times negative 1 is negative 60. Let's combine our like terms. So 152 minus 120 should give us 32x. And then negative 60 plus 988 should give us positive 928. Divide by 32, x equals 29. I asked you to find PT, so PT is from here all the way to here. So we know this part's 60, let's plug in here. 4 times 29 minus 26. 4 times 29 is 116. Minus 26 is 90. Add that to 60, that means PT should equal 150. Okay. Given that these two triangles are similar in a scale factor from WXY to CDE is 4 to 5. So this one's 4, this one's 5. Find the perimeter of WXY. Okay, so let's go ahead and find the perimeter of this one first. So that should be 13 plus 22 plus 29, adding up all the sides, 64. So if my scale factor is 4 to 5, 4 to 5, we want to be perimeter of the right, so x over perimeter of the left, so 64. Cross multiply, 5 times x is 5x, 4 times 64 is 256, and divide by 5, I'm getting a decimal of 51.2. Should be okay. Just gonna double check my math here. Alright, it all looks good. So x is equal to 51.2. We weren't given any measurements, so the perimeter of WXY is 51.2. Next, determine if the following triangles are similar. Justify your answer with math. If they are similar, write a similarity statement. All right, so this one, I know that I have these vertical angles. So let's go ahead and see if these sides are proportional. So the smaller side on the left triangle is 15 over the smaller side on the right triangle is 21. So this equals 28 over 39.2. Let's cross multiply and see. So 21 times 28 equals 15 times 39.2. So 29 times 28 is 588. 15 times 39.2 is 588. Okay, so yes, these are similar through side angle side similarity. I could say triangle PMK is similar to triangle LMQ. So I went down the longer side to the shared angle or vertex angle, down the shorter side. So I follow that same pattern. 13. Okay, so they share angle C, so I know that one is the same for each of them. So we want to make sure that this angle is also 98, so let's check. So angle D, to get that, I'm going to take 180 minus 38 minus 47. And I get 95 degrees. So this angle right here is not 98, so we know that they don't share at least two angles. So I would say these are not similar. Number 14. All right, so we're tackling side, side, side here because we don't have any angles. So let's go ahead and set up our ratios. Maybe this time we try to find our decimals to see and compare. So I'll take the smaller side, 8, over the smallest side, 10. 8 over 10 reduces to 0.8. Next one, middle side, 9 over middle side, 11.25. That reduces to 0.8. And the last one, 12 over 15. That reduces to 0.8. So yes, these are similar through side, side, side similarity. I'm going to say triangle. Let's go short, long, short, medium, long side. So N, R, Y. Oops. Is similar to triangle, short, medium, long. So E, A, D. Okay, number 15. So I can add my vertical angles in here. Okay, and then because I have these parallel lines, I know that angle P and angle F are alternate interior. So I'm going to go ahead and add that these are similar through angle-angle similarity. Triangle PAS is similar to triangle FAC. The next one we should be able to tackle using side, 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 or side, angle, side. If we did side, 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 then we need to set up all three ratios and compare. If we do side, angle, side, we only have to deal with these two sides and these two sides. So I'm going to do that one. So I have 12 over, that's the longer of the two sides, so 21. That reduces to, let's see, 4 over 7. The other fraction, 10 over 18. That reduces to 5 over 9. So these are not the same ratios, so this would be not similar. 17. All right, tackling side, angle, side again. So let's do 32. Excuse me, 32 is the longer side, so over 48. That's going to reduce to 2/3. And 30 over 44. That's going to reduce to 15 over 22. All right, so these do not have the same scale factors, so not similar. Oh, 32. Yes. So not similar. 18. So I'm going to tackle side, angle, side. So I need to figure out what this long side is. So 8 plus 32 is 40. So we have short side. Oh, we need to figure this out. 45 minus 9. Oops. is 36. All right, so we have 32 over 40. That's going to reduce to 4/5. And 36 over 45 should be able to reduce by 9. So 36 divided by 9 is 4. 45 divided by 9 is 5. So these are the same ratio, and they have that common angle. So this is side angle side similarity. I'm going to say that triangle RNV is similar to triangle JNK. Last one on this page. We have the vertical angle, so let's go ahead and compare the ratios now. So we will do 15 over 24. Divide those both by 3, so 5 over 8. And should stay the same way, 20 over 32. Yep, these come to the same fraction. So 5 over 8 divided by 4 that time. Same ratio in the vertical angle, so actually here we have side-side angle. In order to do this one really, we either need the two sides that make up the angle, or we need all three sides, or we need two angles, and we don't have that. So even though that these sides are proportional, we don't have enough information quite yet to say side angle side, because we need this side, or side side side. So I'm going to say not similar, because we do not have enough information. Flip it over. All right. So for 20 and 21, we want to determine if we can state that these triangles are similar. So we want to be able to have enough information to say side, 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 angle, side, or angle, angle similarity. So in order to do that, let's check these couple things. So our ratio from triangle ABC to XYZ is 5 to 2. So we want to make sure that carries through. So this one says that AC to XZ should be 2 to 5. That's not true, because we want it to be 5 to 2. So these two would be possibly correct. The last one says that YZ here should be 5.2. So if this is 5 to 2, we have some missing number. I'll just label it X over 12. Oh, 12 should go on the top. 12 over X. Let's cross multiply. 5 times X is 5X equals 24. 24 divided by 5 is 4.8. So that's saying this should be 4.8. That's not what this says. So not this one. So these next two, if I said that AC to XZ is 5 to 2, so it's same ratio, and then I added in that angle B and Y were congruent, then that would leave me with side-side angle, which is not one of these. So not this one. This one says I would talk about angle A and X being congruent and these sides being proportional. So that would be that one, third side, angle side similarity. 21, similar arguments here. We want to talk about sides being proportional. then our proportion is 3 to 6, so it's twice as big. So 1 to 2. This one says BC to XZ is 2 to 1. That's not true. This triangle should be 1 to 2. We want to add in the angle C and Z are congruent, and that XZ should be 8, twice as big. That follows through, but then that would be side-side angle again. So for this one, saying that XZ should be 8, so twice as big. That's true. And then this one would be twice as big, 10. So C would be true through side, 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 similarity. The last one's talking about proofs, so I'll create a table. I want to prove that these two triangles are congruent, and I was given that angle A is congruent to angle E. The other thing that I can add here is my vertical angle. I need to use 3 letters though. So angle ABC is congruent to angle EBD. And that's through vertical angle theorem. Step 3, now that I have 2 angles, I can say that these triangles are similar through angle-angle similarity, making sure that my proof step looks identical. Alright, the last one here, it says that ABCD is a parallelogram. And the angle CAD is congruent to angle FEC. So let's add that in. CAD, this angle, is congruent to FEC, this angle. Okay, so I'm trying to prove that triangle ACD here is similar to EFC here. So I don't have anything about sides, but I can talk about different angles here. So if I talk about parallel lines, then I can use alternate interior or corresponding angles. So alternate interior wouldn't really get me any angles in this triangle, so maybe corresponding. So this angle C and this angle D would be corresponding if I had parallel lines. So first let's talk about these being parallel. So AD is parallel to CB. Why do we know that? Because opposite sides are parallel on a parallelogram. Step 3, saying that these two angles are congruent through corresponding angles. So I'll use 3 letters. ADC is congruent to angle ECF. Last step, I can go ahead and say through angle-angle similarity that these triangles are similar. Because I have 2 angles, automatically the third one is congruent to the third and the other triangle.